On camera. Okay, hello everyone. Welcome. Good morning or good afternoon, depending on where you are. And welcome to this webinar, the 10 worst mistakes, of line design. Now, when we say 10 worst, is 10 the right number? Well, clearly not. But these are things that have happened to us, either directly in our past lives.
Never happened to us. We have witnessed these.
Rarely happened.
Never happened.
It's rarely happened to us, or that we've observed. So these are all real examples we want to walk you through. And they're all things where we said, gee, if I had to do it again, I wouldn't do that. So, interestingly enough, Gerard, I read an article the other day about a company. I can't remember what which company it was, but they were actually paying people bonuses, paying employees bonuses for mistakes. So every time you made a mistake, you'd get I think it was a $10 little bonus. Of course, don't make that mistake again was part of the deal. But they encourage people to make mistakes and learn in that way. So hopefully we can do the same thing with you.
And again, it's not about 10 or 11, right? Because we could keep going forever based on everything we have seen in the nearly 50 years of experience we have amassed together.
In fact, just this morning, Gerard said, what about this mistake? What about that? We didn't include that. Well, too late.
Yeah, exactly.
Maybe we can have...
we'll go through those 10. We'll mention anecdotally other potential mistakes. But I think that the overall theme of it is you need to follow the method. The methodology that we're going to teach in our online classes and at the Toyota class that's happening week after next, that is really what it's all about. Following a method. Not try to design a line just by being the smartest guy in the world.
Okay, and we have 10 of them. We have an hour, so we have a tack time, we said, of about 5 minutes, 4 minutes, so we really need to get going here.
We need to get
going.
So
we're going to switch over to our presentation and share screen and click, and there we go. So
right now, everybody should be seeing this lady that apparently committed some of these mistakes during line design. And so let's jump right in.
Okay, 10 worst line design mistakes, how to avoid them. Well, before we get into line design mistakes, let's define quickly what is line design, what are we talking about here? And so let's just define it very simply. When we say line, we mean production line, like assembly line. That's what we're talking about. So it's a manufacturing term we're using here. And by design, we mean we're balancing the work, designing the work.
We're looking at designing a set of processes that are linked and balanced. That's our goal. And we're looking at all this within the context of mixed model line design, which is the widest way of designing a line. Mixed model line design, that is our specialty, that is what we focus on, and that is what we believe is the best way of designing a line.
That's our wheelhouse.
That's our wheelhouse. Yeah, that's a term we learned some time ago. We had to Google it to see what it means.
Okay, so here we go. Here's the first one.
Yeah, we're going to do it countdown style.
David Letterman style.
Exactly right. That's an homage to David Letterman. We're going to start from mistake number 10, counting down to mistake number 1. And here it is, the first one. And yes, we have seen this one. Designing from the conference room, not going to the floor. We have seen this one more than once. We're not going to be reading these bullets to you. You can read, right? And the idea behind this mistake is, well, I know better, right? I am the line designer. I am the ME. I know better. And trust me, it doesn't work. You don't know better because you do not experience the process every day, or in some cases, you don't suffer the process every day. So what to do to avoid this mistake of coming up with a line design that looks great inside your head or on paper, but may not work? Well, what do we do about it? What we do is go out to the floor. Talk to the people who live the process every day. They know that issue that you may be thinking about, that instance of waste that you may be thinking about it once, the folks on the floor live it 100 times a day. So go approach the folks that do the work, respectfully ask what are the issues, and you will get a wealth of information that you will not get from the conference room. Make sure that you have operators in your line design team, because every time there is an idea that again sounds great on paper, sounds great inside your head, they will come back right at you and say, well, we tried that in the past, or I know based on the current tools that I have that will not work. And that might cause you to not move ahead with that idea, or to figure out what other resources you need to make it work.
Yeah, a recent project we worked on, I would say hands down the most valuable member of that design team was a guy from the factory floor. Because even though this was a company with basically good data, they weren't starting from scratch. They had decades really of data and good tools and good systems, but there were so many things that were not documented that this person was able to contribute based on his hands-on experience. So really, really, I would say the most valuable member of the team.
The famous tribal knowledge, right? So make sure that you account for that. Value stream mapping. You need to do value stream mapping at the beginning. You will never design a line from a value stream map. You heard that? You do not design a line from a value stream map, but you need it as your baseline from where to start and where to figure out where you start from. Create it on the floor. Go to the floor, observe the processes, document the process right from the floor, and by asking the folks that do the work.
Okay, start at the end. This isn't a hard recommendation, because if you have a very simple line, it doesn't really matter where you start. But in general, on a mixed model line, it's easier to know where it ends than to know where it begins. So if you start at the end of the line, say in pack or at the end of a production line, and work your way upstream, you're going to get a more accurate picture of how things come together.
And this particular recommendation is going to really apply when you have a line that assembles, packs, and inspects at the end, that has a lot of machining processes at the beginning. You really want to start at the end.
Or a lot of sub-assemblies.
A lot of sub-assemblies. You want to start at the end, the point closest to the customer, get that under control, and then from there, go upstream. Don't start, rarely we would recommend starting machining, because you don't know the impact on the downstream processes.
Okay, so the lean phrase here on this mistake, let's move on, right?
Yeah.
Is go to the Gemba.
Right.
Go to the Gemba. That's exactly right. That's the summary of that one. Case history. This is one.
Yeah,
you worked on.
This is one of mine.
Okay, you got a tack time of 60 seconds. To
I have just a few seconds to talk about this one. This is one of mine, and again, this was one of those projects in which I was given the best and brightest. Frankly, honestly, the best and brightest. All engineers, all new, and I asked them between visit 1 and visit 2, go ahead and create all the process flow diagrams, right? And I came back on visit 2, and they had created all the process flow diagrams from the manufacturing engineering documentation, all from engineering documentation, never set foot on the floor. So I said, okay, let's go out to the floor and check them out. Why? These have all been created from the way they should, from the way the work should be done. I said, yeah, but humor me. As we're looking through the process on the floor, an operator walks past us, looks at the page we're reviewing, and says, nah, we don't do it that way. So I had to chase him and ask, hey, what's the story behind this? And the answer was, well, I know this was designed this way, but had we followed this process, we would have never completed one of these gas turbines for you. So there were many workarounds that were developed on site right at the moment by the operators. Without those workarounds, that set of processes would not have worked. Now, am I condoning workarounds? No, but sometimes we give operators processes that require workarounds.
Okay, there was a quick question. I'll try to answer it briefly. Value stream mapping. Gerard said we don't design from a value stream map. Let me just give a quick answer to that. Value stream mapping is done at usually a product family level. And when we're talking about line design, we need to drill down. So there's not enough detail really in a value stream map to get to where we need to go in terms of calculating resources. In a mixed model line, we need to take it all the way to the individual products and the mix. And you don't see that on a value stream map. So we say do it, but it's a high level kind of vision statement.
Yeah.
And when you get into the actual line design process, you need more data and more details.
And I know that some folks that may look at value stream mapping as a very useful tool. May want to argue this one, but value stream mapping is an assessment tool. That's what value stream mapping is, an assessment tool. It's not a line design tool.
Yeah, so let's move on, but hopefully we answered that in sufficient detail.
All right, next.
Let's see.
Stay on that one. There you go.
Let's see. I'm trying to click to the next one.
Click on the PowerPoint slide on that side.
Yeah, sorry, folks. Just a second.
Oh,
There we are.
Oh, okay. All right. Got it.
So moving on to the next one.
Okay. Not understanding process, quote unquote, or what a process is.
And this is something we spend a lot of time in class. What is a process? A process is a set of tasks of common work, normally done at a fixed location, and that takes place at constant volume. So sequential work at constant volume, like work. That is what a process is. And many times what happens is that folks misinterpret what a process is, and you end up with one of the first key steps, the development of process flow diagrams, well, not done correctly, and that causes problems because that is the foundation, the process definition and the process flow diagrams.
Yeah, and the same concern applies to value stream mapping as well. What is that box on a value stream map? What's contained in that box? That needs to be clearly defined, because otherwise you're going to get value stream maps or process flow diagrams that are way too complicated or way too simple.
Exactly.
And
Too simple means you're flying too high. Way too complicated, you're lost in the weeds.
Okay, so let's look at the solution. So we're talking about definition of a process here, just for clarity. So a process contains work of the same type. So don't mix work of different types.
Exactly.
Test and assembly are different processes.
Exactly right. Test, assembly, pack, different process. When you walk the floor, you will be able to identify, but that's the easier first step, identifying, drilling and punching and bending. The next step is the work needs to be sequential. There may be assembly of the chassis and assembly of the transmission. Both are assembly, but if the work can be done in parallel, it's not sequential, then you're looking at different processes. So sequential work of a like kind.
Yeah, so just to repeat, if you have work steps and you could do some of those steps in parallel with the other work steps, that's a different process. It should be identified as a different process, because you might want to set up that as a feeder line and reduce your manufacturing cycle time. So there's the issue there. Recommendation here, if you have a large machine, say a machine that requires a capital investment, not a tool, but something larger than that, call it a process by itself.
Yeah.
Why? Because it's going to really simplify your analysis further downstream when you get to calculating resources.
Yeah, and it tends to satisfy all the elements of a process definition, which the last one is constant volume. As long as the volume remains constant, you have a single process. When the volume changes, because you have changes in work time, changes in bill of material quantity, scrap or rework or options, anything that changes the volume, you're looking at a different process.
Yeah, I think this is the hardest one to understand,
Yeah.
I think, is the change in volume. So we usually spend more time on that. I'm reminded when I look at this of my very first lean project. I mean, the very first one as a lean consultant, where my colleague and I walked into an air conditioning plant, as it happened to be, in the state of Missouri. And we looked at each other and he said, I think we're in trouble. We were both pretty new to the company. And I said, well, why are we in trouble? And he said, because I'm not even exactly sure what a process is. Well, we learned, but I'll have to admit it does take a little working with it to really grok it.
And why the constant volume feature, why is it so important? And it's the most important one, because one process equals one takt time. One process has one takt time. There is no more than takt time per process. One process, one takt time. And that takt time is completely dependent on the volume. When the volume changes, takt time changes, process changes.
Okay.
Now, the case history in this one, and again, not naming names, one of my clients that's in the business of building very large pieces of equipment. In this particular case, they make very large fork trucks, and these particular ones are container pickers. When you look at that final assembly line, you can look at it in two ways, one correct, one not so correct. As long as the volume changes, as long as the volume remains constant in that final assembly process, you have one process called final assembly. But sometimes there is the tendency, and you can see this mistake, even though the volume is constant and the work is of a like kind, to overly fragment that final assembly process and end up with multiple pseudo processes like chassis assembly, like install transmission, install hydraulics, install cab. Every time you see those processes that go install, you're looking at a chunk of the standard work definition, which is the document where you document the standard work. As long as the volume remains constant, do not over fragment your process. If not, you're going to cause some serious complications in your resource calculations, your balancing, and the documentation.
Yeah, it doesn't mean they would be wrong. It just would be much more complicated than they need to be, which adds problematic factors to your analysis.
Hence, making it a mistake.
Yes.
Right?
Correct.
One of those
Right.
10 mistakes.
So we go on?
Oh, yeah.
Counting down, mistake 8, misconnecting upstream processes. We were
Yeah.
trying to figure out how to describe
Yeah,
this.
this is not even a word. We just couldn't come up with a better terminology. But think about this. Approaching a line design with a dogmatic point of view and saying, well, this is mixed model flow, everything will flow. Everything will be connected and everything will flow one at a time.
Yeah. Or the value stream will be complete from the very beginning to the very end.
Boy, and that's a discussion we have with folks that, I'm a lean guy, right? And a value stream is this, right? That's not an argument I'm interested in having. We're practical and we want lines that flow, right? But if you approach this dogmatically, you may end up with such a ridiculously complex set of process flow diagrams because you want to connect everything, right? That then you never finish this line design. So think about it, and this problem applies very commonly to lines where you have a significant portion of the line is line assembly, test, and pack, those final processes on the way to the customer, and then a lot of machining processes upstream from there. Connecting those to the line is a nice thought, but many times not practical to do. So all those fabrication processes, attempting to incorporate those to the line without thinking about the practical implications of that can really lead to disaster. So learn material Kanban. The Kanban supermarket can be your best friend here and actually save your line design and make sure that your line design does work. So Kanban is an excellent solution when you have machining processes. Now, are we saying that never a machine can be connected to a final assembly process? No. As long as the machining process can support the takt time, the required takt time, that's perfectly okay. But many cases, machining process are going to have limitations like changeover, and changeover is very likely
And remember,
to make that impossible.
Kanban is a form of connection. It's just not a direct connection.
Exactly.
So-
So not a one-for-one.
So basically, whenever you have a fabrication department or machining upstream, especially when you have changeovers, you're pretty much looking at this solution.
Yeah.
Okay, what else? Don't include on the process flow diagram. So we're saying here, if you have upstream processes, especially with changeovers, feeding a supermarket, you need to design that part of your factory, but treat it as a separate project.
Yeah.
Treat it as a standalone kind of initiative.
I remember a project where we had every product they manufacture was basically like this. The final processes were powder coat, assembly, test, and pack. Every single one. From there upstream, it was a myriad of processes like cutting, bending, punching, hemming, tack welding, finish welding, tons of processes that if we were to show them on the process flow diagram, the process flow diagram looked like a bowl of spaghetti, right? That level of complexity can kill you and can make your line design unattainable. Separate the two. In basically, you end up with two line designs. One line design for the assembly portion, one line design for the fabrication portion.
Okay, now if we have a Kanban supermarket, that implies more inventory than maybe you would like, but you can work with that over time, and that's principally related to the amount of changeover that you have in that area. So the lean tools of SMED can be useful there, and just work to reduce changeover time. As changeover time goes down, your quantities in this Kanban supermarket will go down also.
Yeah, I'm sure, Richard, you remember the case of that fan company. Where were they? They were in.
That's our case history, right?
Yeah.
That's an Ohio company. I was called in on this one. I didn't. I'll have to confess to you, I didn't cause this issue, but I was brought in to try to fix it. But if you look at a fan like this, and just imagine that we're doing all the fabrication for these parts. We're not buying them. So we're doing all the sheet metal work in-house, the fan blades even, and then we're buying the motors and we're putting this all together. Well, what could be easier, right? You might think on a project. And they had different sizes, right? Big fans, medium-sized fans, but they were all pretty much the same. It was a box with a motor and the fan blades and a drive belt. So pretty much all the same. Well, this turned into a nightmare because the lean team was trying to connect all of the fabrication work to the downstream assembly work and pack via the same process flow diagram. And I don't know what they were thinking, but in their minds, trying to flow everything from the raw sheet metal all the way to the finished fan.
And try to do all the resource calculations all at once. And in Woodward, they ended up with process flow diagrams that was like 50 processes each or some
It was
really
horrible.
unmanageable.
But when you look at this picture, you realize that all these sheet metal parts are essentially going through the same machines with changeovers. So it was a mess, to say the least. That was one of the...
And shouldn't have been.
Shouldn't have been.
That's the crying shame. It should have been an easy line design.
Yeah.
Done right.
Yes. And so again, to recap what we just said, what they should have done is just focus on downstream assembly. Treat all these fabricated parts as if they were purchased parts, and just design the downstream common processes like assembly and pack and test, and do that, and then shift their attention to the fabrication department, gather all the part numbers that would have to be produced in that, including the run times for these part numbers, the changeovers, and we have a methodology in our mixed model line design workshop that helps you do that kind of analysis and actually design this fabrication department.
And just for good measure, just want to make sure that you're not interpreting or you're not thinking that what we're telling you is ignore fabrication, ignore machining. No. Just treat it as a separate line design.
And typically it's feeding a Kanban supermarket and not being connected directly. All right, should we go on?
Yeah,
How are we doing?
so.
It's 11:21. I think we're doing pretty well.
I think we're doing
Under-resourcing options. This is another one of my favorite ones.
Yeah, as a matter of fact, we have an entire graduate webinar on just this, because this is one that will happen. And the example I always like using, because I remember my first brand new car was a Honda Civic, and I wanted it with a sunroof. And I thought, well, if not all of them have sunroofs, which they don't, then how do they design this process, the sunroof process, right? The sunroof process is some percentage of the total. So what happens if on a certain day, everybody wants sunroofs? And that is what this is all about. Not every process is 100% process. Some of them are optional. You will see that on your line design. That has to be accounted for. We teach that in the workshop. But then there is the operational side of it, right? How do you deal with optional processes when they are not 100% options?
Okay, so let's look at the solutions here that we're suggesting. First one is sequencing. So if you have optional processes and you don't want to way over design that process, which is going to be another suggestion
Which
here.
sequencing is pretty much mandatory.
Yeah, sequencing meaning put it in an optimal order. To give you a simple example, the sunroofs. If you have a 50% option for sunroofs, you don't want to put two cars that require a sunroof back to back in the line. Now, you may not be able to control that. So that's another issue, separate issue. But in general, mixed model manufacturers pay a lot of attention to sequencing.
Yeah.
So you don't overstress these optional processes too much.
But sequencing, although it's mandatory, will not be the 100% solution. You will need to use one of these following strategies. And one of them may be over-resourcing. So if you have an option that is a 50% option, right? What happens with takt time is twice as long. So what's going to happen when you calculate resources is what's going to happen there is that you're going to calculate fewer resources that you would have calculated otherwise with a shorter takt time. So then you have a 4-minute takt time feeding a 2-minute takt time line. What happens? The option cannot keep up if every product is requiring that option. One solution, potential solution, and one we implement a lot is if the capital expense is not enormous, if it is affordable, if we're looking at benches and hand tools, we normally, well, for lack of a better term, fake the takt time of the optional processes. We force it to be 2 minutes. We increase the number of resources. In that way, it can operate at the same takt time that the consuming process requires. Now, that does not mean we add more people, all right? It doesn't mean we automatically add more people. So over-resourcing, one of them. The other one is potentially a FIFO lane, and that means you keep the number of resources the way it is, but you add a location for inventory to allow you to overcome that takt time differential.
Right. So FIFO lane would be a buffer of a certain number of units that will allow you to run a certain number of these products, consuming that option back to back without delaying production or slowing down the line. But that's only good for a certain number of cases, certain number of incidents of that back-to-back production. So FIFO lane is not going to be if you can't sequence, FIFO lane is not going to necessarily.
Again, it's not the 100% solution, but it will definitely ameliorate the problem.
Yeah. And of course, the final solution is going to be all of the above. FIFO lane, over-resourcing, maybe not to 100%, but to some level based on your history, analyzing your past history of demand on that line. Sequencing is pretty much in every case a requirement. And did you already say this? We're not when we say resource, we're not talking about people. So you have to be considering the ability to move people in and out of that process, which is another interesting issue that we'll be talking about in an upcoming webinar.
Indeed.
Yep. Okay, so case history on this. Oh, don't overstaff. Okay, I guess that repeats that recommendation. Don't just throw people at it. Now, this is a case history that, again, I was involved in past years. This was a radio. It was like a private cellular radio transmitter that looks kind of like this box you see here. And one of the options was a fan. And it was based on past history, and I think we even rounded up a little bit, was about a 50% option on this cooling fan. And so this happened to us, kind of embarrassing. On day one, this was kind of a big deal. We were bringing the line live, and I think even the local newspapers were there, and management was there. And so this whole new layout and new line started running. And the first machine coming down the line needed this optional fan. You see the little checklist there. And the second one needed the optional fan, and the third one needed the optional fan. And by the way, the optional fan was not something that you could really sequence for, because there were a lot of other sequencing rules, and the fan wasn't one of them. So it wasn't even something that we can control. And the poor guy in this 50% designed option is starting to sweat and trying to keep up, and all eyes were on him because that line was dead. It was stopped right at that where that optional fan was consumed. And there was no additional inventory, by the way. So that was embarrassing. And fortunately, it was just, as Gerard said, just a workbench. So we were able to kind of think on our feet and pull in another workbench, add another person, and get that flow up to where it needed to be. but that really shouldn't have happened.
Yeah, easy fix, overnight fix. And by the way, that's something we strongly recommend for those of you aspiring line designers, and that is the first few steps the line takes. You have to be there hand holding, and some of these fixes, overnight fixes, you need to be ready for those.
Okay, next one. Mistake 6, excessive operator part selection. This is a big one and sort of a sometimes hard to appreciate.
Yeah,
Waste.
and we have gotten in trouble at times by suggesting that well, there are better ways in some cases to provide materials other than Kanban. Oh, some people just are so enamored with Kanban, which, by the way, we teach Kanban. We love Kanban, but it doesn't mean Kanban doesn't have some shortcomings. One of the shortcomings is the general idea behind Kanban is that in front of you, you have all the materials you could ever need to build any product you could ever build, right? So then here's the problem. If you have too many parts in front of you, do you think that every now and again you could make a mistake? Maybe. Do you think that if you have too many or lots of parts in front of you, you have to take some time to identify the part that you need, and that takes time and that could cause a problem? Sure, too. The shorter the takt time, the more challenging this gets. As a matter of fact, we're beginning to see and we're beginning to implement different strategies to change that. We are relying less and less on Kanban and more, and here comes a bad word for those of you lean guys.
The K word?
Exactly right. Kitting. We're relying more and more on kitting. It doesn't mean MRP kitting, not that. That is bad. I agree with that.
Yeah, and by the way, one way to detect this in your particular plant is to videotape processes and then just sit down and watch that video and notice how much time the operator actually takes retrieving parts, sometimes even walking away from their station to get parts. That's not unheard of by any means, versus actually adding value. And it sometimes could be shocking. And that's the issue we're trying to address here.
Yeah.
Right, so let's look at some solutions. Well, provide exactly what is needed. That's the K word here.
Yeah.
So
well, we designed a line with products being built on an AGV moving station instead of a conveyor. And the first, I believe, 6 stations on that line were picking stations, where the AGV runs through the supermarket, pick for that one product, and that workstation with the parts in tow stops at each individual workstation, builds the product, and moves on.
yeah, in that example, the only parts that were Kanban were common hardware items that were actually stocked on the cart. But basically everything else was just delivered to the operators at various stations in quantities of one.
No
exactly
doubt,
what they needed.
No doubt, not a question what needs to be picked. What goes on this product? Well, you have it right there.
Yeah. Now, represents this whole discussion, in my mind, maybe I'm biased because we've talked about Kanban for so many decades, really, but it represents a sea change, I think, in terms of lean thinking, being more open to this idea of Kanban instead of viewing it instead of viewing kitting as wasteful activity, adding more labor, people are starting to view it as really a viable strategy to reduce floor space, to improve the quality of part selection, meaning not picking the wrong parts, and actually improving productivity on the line. Because remember, you may be adding people to do kitting, but you're also potentially reducing time for the operator, from the operator point of view. So the real concern is not the fact that you may have to add some people doing kitting, it's what's the net effect.
Exactly. Now, are we saying that is the only and 100% solution? No. Kanban in many cases is the right solution, but we have seen kitting work very, very well on mixed model flow lines. And as a matter of fact, I think in our case study that we have in a few seconds, we have an automotive company reporting substantial gains in productivity thanks to kitting.
Yeah, and especially if you notice, if you look at a video of people working and you see that people are leaving their station and having to go retrieve material, that's that's a big opportunity usually to improve that. So reducing motion at the workstation.
Yeah.
So here's an actual case history. This is something I saw. This is some of you may have actually been here as well. It's the Toyota plant in Georgetown. And I had a chance to take a tour there last year. This is actually a photo of the new Lexus line at that same plant. So they're building the ES350 models there. But I was surprised actually to see at that Toyota plant that most of their feeder lines, say engine prep, dashboards, they didn't let us get too far into the building on the tour, but all the processes that we could see were pretty much kitted. I didn't see very much kanban in front of operators, even down to the level of hardware. What was happening on many of the lines is there was a small kitting cell, not somewhere else, but right next to these various feeder lines that were preparing these kits, and then an AGV would deliver trays of parts to the line. And that, I was expecting to see, because Toyota is kind of known for their as being the originators of Kanban. I asked some of the managers there about that, and they said, yeah, it was something relatively new. That's why I mentioned the sea change word. Just in the last few years, they've been trying this. And I said, well, how's this working out for you? And he said, well, I don't have facts to back this up, but just anecdotally, 5% gain in productivity, which for a line that was already pretty lean is not too shabby, and improved quality, so reduced mistakes.
Primarily picking errors.
Yeah, and the most important goal, the reason they even pursued this was they were running out of space, physical space. So they're able to shrink those assembly lines down significantly, as you might imagine, right? If there's no line side material in front of the operator. So interesting, and at least at Toyota, we saw some of this in action.
Yeah.
Okay.
And we have implemented ourselves that strategy on some of our client lines.
Okay. Quick pause here. We have an opportunity for you. We are actually teaching a mixed model line design workshop. I want to mention this quickly. At Toyota Material Handling, that's in Columbus, Indiana. It's coming up on March 8th through the 10th, 8, 9, 10, where we talk about a lot of these issues we're talking about now, but in a lot more detail. And this question about using value stream mapping for design, well, you're going to have a chance to actually learn our line design methodology in detail, which is really, from our point of view, something that every lean or manufacturing engineering specialist needs to know. I mean, it's a core skill that you need to have. There's a little box on the right side of your screen here that you should be able to access with a special link, and you can get $300 off of that class. So it's coming up. I know time's running out, but we do have some seats available. So if this is of interest to you, or if you want to find out more about it, just give us a call, contact us, and we can tell you. That's coming up on March 8th for 3 days in beautiful Columbus, Indiana, the 6th most architecturally recognized city in the United States.
Indeed.
Yeah. All right, continuing on. And we're at 11:36, so we'll turn up the gas a little bit.
Yeah, we're still doing all right.
All right.
And one of the steps that we teach in the roadmap for line design is designing the line at a conceptual level. Forget CAD, forget all the potential constraints, design an ideal line. And some folks don't believe that because they think it's waste. As a matter of fact, it's exactly the opposite. It's the best way to design line, because many of the compromises you need to make, many of the thoughts you need to have happen during that conceptual phase. Then you move to CAD. So make sure that when you are designing a line, start with the block layout, start with a conceptual line design, then move to CAD.
Yeah, a lot of you are great. A lot of you people listening, I'm sure, know AutoCAD. You can do it yourself, and there's that strong temptation. Right?
Yeah.
You just fire it up and start doing the layout.
Don't.
And thinking that you're going to save time, but you're not.
No, you won't. Because if you start going down a route that then you end up not liking very much, there is a pride of ownership that develops with that CAD layout. Believe us, we've seen it.
Or even if you don't have pride of ownership, the amount of work you put into it
Exactly right.
just makes it painful to change.
Exactly.
So if you have Post-it notes or some kind of cutouts, paper cutouts, maybe even if they're dimensionally correct, but they're easy to move around on a conference room table, and you can experiment with a lot of different options, get feedback from folks before you commit to that CAD.
And from here, before you even do CAD, we recommend that you think about doing your simulation model from the conceptual line design, then move to CAD. Once you've proven your conceptual line design with a simulation model, then go to CAD.
Okay, so needless to say, you will need CAD.
Yeah.
Right.
So in this is not a case history, but this is an anecdote. I am speaking about this to a class, and in the manufacturing, I have a group of manufacturing engineers that are telling me that, why don't you teach this to our bosses, because they don't understand that, and that's something we teach in class. It is very important to have a good level of line design knowledge at all levels, right? From management on down. And as we finish that portion of the discussion, I call for a break and a phone rings. One of the manufacturing engineers takes the call, and after the call, he's shaking his head and says, "You won't believe the call I just got." What is it? My boss asking me to whip out a line design on CAD by the end of the week. And again, that is just basic lack of understanding of the fact that a line design is not something you whip out. It's not something that you finish in a couple of days. It takes method, it takes time. Again, not years, right? Not months, but it takes method, it takes time, and it takes understanding.
Yeah, it could be months.
It could, yeah. Could be months.
Yeah. Okay. Thank you. Not using IPKs, mistake 4. So IPK, in-process kanban. So this is a space or buffer, within the line itself to store WIP or partially completed units. That's what we're talking about here. That's our definition. And we've noticed that there's some lean aficionados who are opposed to the use of these buffers, considering them a form of waste, right? So,
any form of inventory is bad, and we will not consider it. Well, you're wrong.
and this is this discussion of IPKs is actually not a matter of opinion or just of preference. It's a matter of system dynamics, right, and time. And this is especially true. It's a matter of science. And this is especially true of a mixed model line. So we have different products with different work content. So we're not even talking about just normal human variability. We're talking about different work time that it takes to build these products. And to expect a line to flow smoothly with no buffering in it whatsoever, you're going to degrade your performance. That's just the bottom line.
It's a recipe for disaster. So do not design a line based on dogma. Design it on base of practical principles. And the use of in-process kanbans is a very practical way of designing a line. So learn all the different ways in which IPKs can be implemented, different ways of calculating or not calculating, using IPKs and the rules for them. So make sure that you do learn that, you know how to use them.
A FIFO lane, for example, is a form of IPK.
Exactly right.
Okay. So large unit, there are cases where it's going to be difficult to use buffers or in-process kanbans, admittedly, or where they might not be needed. Like if you have a very long takt time, you may not need to buffer as much because people are able to move and flex.
And you can absorb the variability within that long takt time. We had a colleague that every time we had a line with very low volumes, he said, "Oh, that's an easy one. I can balance that one using a sundial," right? So long takt time is a very forgiving line. Unlikely you will need those.
Or large unit. I mean, if some of you might be building big green tractors.
Yeah.
I don't know. Just guessing.
Just guessing.
So that might be difficult as well. You're going to double the length of the assembly line. You can try to put a tractor in between every station.
Just won't happen. You will have to be extra good at balancing. That's all there is.
Now, when people say, well, okay, we can fit them. It's not a large product. It's not an excessively long takt time. How many should we put? The default is 1. The thing is, unless you're using simulation modeling, there is no actual formula that's going to tell you how many, but 1 is a good starting point.
Yeah.
The law of diminishing returns on IPKs kicks in really fast. So start with 1, and then we can talk about cases where maybe more than 1 are going to be needed.
Now, those of you who are going to start typing notes, yes, there is a calculation that we teach, but that is for the balancing tool called inventory and time.
Which is different. Yeah. All right. Now, test with simulation. Simulation is a great tool to test buffering. test the number by
Absolutely.
decays, because you can very easily put in the number and run the model and see what happens, as opposed to testing that in the real world.
Yeah.
So again, in general, we're big fans of simulation. We're going to talk about that.
We see it almost as mandatory.
Yep. Okay, case history. Was this mine?
Yeah, this was yours.
Yeah, this was just a few days ago. I thought this was timely. I was meeting with, it's actually a simulation guy, representative from one of the simulation software companies. And he was telling me about a plant tour that he was able to take just recently. I mean, just a few weeks ago. And it was a automotive component manufacturing. It was a line doing brake pads, I think it was. And there were a series of machines set up to flow the work. And this team had decided that from a lean philosophy point of view, no buffers.
And it was sold from a company to another, and the company that acquired it said, "Oh, look at all those buffers.
Look at all this waste, right?
Exactly right.
Take the waste out." But some of these machines had changeovers. So he said he's watching the line, and anytime there was a changeover, this cell or this line would stop running, obviously, and the throughput was horrible. So that's a case where clearly the lean philosophy got in the way of common sense.
Yeah.
And
that hence this picture here. Don't go to a line design with a head made of bricks. All right.
Cement head.
Exactly right.
Okay. Next one. Too much line side material. Oh. Okay.
Yeah. And this is one of those cases in which you could end up with a bad line design on the basis of groups not working together, teams not working together. And normally you want to see two teams, and we sometimes call it the process team and the product team. The process team is working on linking and balancing the processes, while the product team working together, they're working on materials flow. And what happens when those teams don't work together is that the process team gives the product team a line design and say, "Here, figure it out," right? And you end up with a line with no room for delivery routes that must be designed. Delivery routes are not going to happen by themselves. You have to design them. This is all about designing. And for those of you material folks that think that, well, I'll just put enough material so they stop bugging me, more is not better. The piles are not your friend. So make sure that the right amount of material is available and no more. Our general target is try to stay at 1 day or less. All right? Target 1 day or less. Design the supermarkets. Again, the supermarkets don't happen by themselves. You have to design the amount of inventory in them. You have to design how that inventory is going to be accessed, is going to be stored, is going to be retrieved.
I know you have your different case history here, but yeah. I remember one where it was a line, and this may strike a chord with some of you. It was a line where the material coming from the warehouse to deliver to the line was like the Roach Motel. It can be delivered, but it can never leave. So any material, even if you have to deliver a box of material, you only need a few parts in that box. That box can't go back to the warehouse, was their policy.
Oh, yeah.
So you can imagine after a few months and years of running this line, what that looked like. Massive amounts of material.
Yeah, and actually, Roach Motel is one of our dear colleagues' favorite expressions. And I remember in South Wales, this colleague I'm talking about, David, spending days cleaning up a line of stuff that's been there forever. And they had this structure, this shack there that was full of stuff. And again, it took David with these folks days to clean that up. And again, this has to do primarily with not designing the line as a team. This could also be reworded as materials design as an afterthought. It's not. You're not working by yourself in a box. You're working together as a team. So we're down to the last two.
Okay. Overstaffing.
Yes. A good mixed model line design must have empty stations. And I know that for some of you, this is like a capital sin. Every workstation must have someone, because an empty workstation is a form of waste. No. An empty workstation is an opportunity to implement flexing. And flexing is one of the biggest opportunities lost in flow lines, because there is a lot of productivity to be gained. So a good line design will have more workstations than people. We're not telling you to understaff with respect to your calculations. You will calculate a number of people. Don't round up at the process level. You round up at the flexing group level, right? And with that, you will get productivity gains pretty much instantaneously.
Yeah, we have a webinar a week from today.
From today, yes.
Yeah, a week from today, one of our graduate level webinars on this very topic. And we're calling this the biggest lost opportunity of lean, right? That universally is not being taken advantage of.
Yeah.
But needs to be.
Absolutely. Flexing is one of the most powerful tools, and yet it costs nothing other than training the folks to do.
Maybe some additional space, maybe some additional resources. Right?
Yeah, but training the folks to do this. Observe the line. This is how you learn if flexing is possible. Observe the line. If you see people standing around waiting for product to come to them or waiting on the next person, you're missing the opportunity for flexing.
Yep. Okay. Now, flexing, this whole strategy goes hand in hand with some of the tools we've already talked about. So IPKs, buffers as a signal for to know when to move and when to stay, and then clearly this is something you want to do anyway, I'm sure, but cross training is a requirement. So people need to be certified to work at more than one station.
Yeah, a typical rule it doesn't apply 100%, but a typical rule we teach is that to work at a flow line, a person, an operator, must be trained one up, one down. One workstation upstream, one workstation downstream. And this is a pretty good book from Productivity Press. It's a collection of articles, and there's an article there that we read a long time ago. It's from like 2003. I don't like the title particularly, but I do like the content of it, and that is on the self-balancing effects of flexing. How a line that's not perfectly balanced, and every line is not perfectly balanced, then with flexing you help achieve that balancing during the daily operation.
This is on page 91, I believe, is the article. So this is
you
a series.
Remember the page?
Yeah, remember the page number. And the basic results of this, the author was describing in a company that he was working with, was basically from one day to the next, or from 1 week to the next, on implementing this technique, 30% productivity gain instantaneously.
I have seen that myself in some of our line designs. You may recall our friends from Ohio, where we had that line. We designed the line making air conditioners. Mm-hmm. Flexing there was absolutely pivotal in improving the productivity at that line. We improved that productivity by 25% from day one to the end of week one.
Yeah,
we brought it live.
And if you don't do this, then you're engaged in a constant struggle to balance the line and smooth. But just keep in mind, in a mixed model line, sure, you need to do that. I mean, it's an absolute requirement to do the best job you can. As
a matter of fact, in the upcoming class at Toyota, we do an actual simulation using you, the students, as the operators, and we see 25% improvement right there on that simulation.
Yeah.
So you'll get to see it yourself if we see you at Toyota.
Yeah. So really great topic, and we'll be talking about this a lot more next week during the webinar.
An entire 90-minute webinar.
Okay, mistake number one. So 11:52. Hey, I think
we're doing all right.
We can just kick back. We
let's
can just blab a lot more. We've got 8 minutes.
Talk slow.
Okay, not testing mix and volume. This is really, I think this actually is mistake number one.
Yeah.
I mean, it deserves to be in the number one slot in terms of importance. Although they're all important. But in this case, we're talking about coming up with a static line design, meaning based on data and spreadsheets and numbers. But the challenge with a mixed model line is simply this. You're going to design for a certain mix, right? What choice do you have? So you're going to take a forecast of anticipated mix and volume of products to design to, but you know that as soon as that line goes live, you're going to be actually building some other mix because you're going to be building what customers at that point in time in the future actually want to buy. The likelihood that that's going to match what you designed the line to do is, I think we can safely say, zero, right? It's going to be something different. So unless we can anticipate and test changes in mix and volume, then we could find ourselves in some uncomfortable situations where we're not achieving what we need to achieve.
So you know what's coming: simulation, simulation, simulation.
Yeah.
Now, are we saying that simulation is necessary for 100% of all line designs? No, there are some that clearly don't need simulation because the times are forgiving, the times are very predictable, but
Very consistent.
Very
Yeah.
consistent.
Yeah.
But as soon as you add any variability to times or to the standard work or to the product mix, we strongly recommend that you use simulation. And you know, this is the 21st century. Simulation is not as expensive as it used to be. This is something that you should consider as a requirement for every line design. So develop an expert, an in-house expert, someone who understands simulation in your plant. Not everybody needs to know simulation. Not every line designer needs to know how to build a model, but every line designer must learn how to interpret the results. So that is very important. As a matter of fact, in June, Richard, we're teaching a 3-day workshop only on learning how to use the results of simulation. So we're going to teach you to build a model, but that's not really the goal of that class.
So let me do something right now. This is on June 21st, 22nd, 23rd. It's going to be hosted here in beautiful Colorado, early summer, right?
Yeah.
Great time to come. And you'll get the simulation software. You get to bring it home with you, a simplified tool that you can use as well. But let me do a quick survey of you all listening. I think we have 77 people on the line. Could you just go to your chat box, and if you'd like to find out more detail about this simulation class, because we're still in the planning stages for this, could you just type yes in your chat box, and that'll give us some idea of the level of interest that's out there right now. So I appreciate that. If this is something you'd like to, you're not committing to it, you just want to find out more, get the brochure, or when we have more information available, we can shoot you an email to let you know what's included in this class. Just type in yes, and that'll give us some idea of the level of interest, because that's important right now.
So simulation, again, it's not necessary that you become an expert in building the model, but yes, in interpreting the results of the model. So budget for it, some amount of money from your entire budget on the line design, plan on it. We are here giving you an approximation of 10%. So think about, again, right? Think about the wind tunnel idea. Do you want to be the first one to fly that airplane?
Let's fly it and see if it works.
Exactly right. Right? If you're building snow plows, yeah, it's no big deal. As a matter of fact, I remember that from.
Well, you're on the ground anyway.
Exactly, from one of our clients. How do you test these snow plows? So we just put them on a truck and just go out and see what happens. How many trucks have you wrecked? Oh, well, we twisted a few frames, and they actually did. But you know what? It was better than they twisted the frame off their own test trucks that your own, right? And you remember this one, Richard, the case of and again, we're withholding names here, of the computer manufacturer that went through a complete line design that included all their warehousing needs, and they never simulated this, even though they should have, because if a computer manufacturer cannot afford simulation, then who can, right? And before they brought it live, they said, well, let's test this. Let's bring simulation experts and see what happens.
Yeah, actually, the challenge for this company was, how much staging area do we need, right?
That was the key.
Because customers would provide orders. These are PCs, right? But the customer would give them orders in varying quantities.
Yeah.
Now, some manufacturers restrict the size of the order quantity, right? So you can order 10 orders, but there's a maximum quantity in the order. This company did not. So the order could be really any quantity, from a very large number of units to small, and they had to ship complete, once they're done. So the challenge for them was, well, how much space do we need? So just to make a long story short, they decided, based on static analysis, they did some, back of the napkin or spreadsheet analysis, and determined they needed about 25,000 square feet. But then before they pulled the trigger on this design, they thought, well, maybe we should be a little more scientific about this. So they hired a simulation expert that we know to do this analysis, create a model, right, and model the units going through the line and then being stored and calculating the storage space needed. And the answer was 100,000 square feet. And so, of course, now they had to choose. We go with 25 or 100,000, and they made the logical decision and said, well, the model's got to be wrong, so let's go with 25,000. And that did not end well, I'll have to say, and they apologized profusely later on. It was actually a disaster for this company.
Mm-hmm.
It was actually a disaster.
Yeah.
So we'll leave it at that.
So
these are, if you avoid all these things, this is just a quick summary of the kind of benefits we want to see, or that you want to see. Shorter manufacturing cycle times, really a huge goal. Faster customer response is related to that. Quality improves. These are all just general lean benefits.
yeah, these are the benefits we teach for the mixed model line design workshop that you can see from implementing a mixed model line design. But there's one in particular, this one, increased flexibility, that we want to spend some extra time on, and we will spend that time next week. In class, in our 3-day class, we teach the topic of flexing, but only so much time we can spend. Next week, we're going to spend 90 minutes only on flexing. We're calling it the biggest lost opportunity in lean. We're calling it a graduate level webinar. So you need to understand what flexing is before coming in, but we're going to dive deep into flexing because lots of people talk about it, but very few people know what they're talking about. So I want to teach you what flexing is and what flexing is not. The fact that it's based on rules, and why are there some companies that don't like it? Well, basically because they don't understand it. So we also want to teach you about the self-balancing effects, and we're going to show that using simulation modeling. What are the requirements of flexing? What are the benefits of flexing? And I'll just spoiler here: huge improvements in productivity. All right. Well, we hope to prove that, showing you.
Yeah, and not just sharing with you our opinions about this or concepts. We're going to actually build simulation models, or not build them with you, but show you the results of simulation modeling that confirm what we're saying.
Confirm that
as
flexing
evidence.
is a very powerful tool. So please, you should be seeing now your opportunity to sign up for this graduate level workshop webinar, and we hope to see you there. So we have come to the end of it with we only took 1 extra minute of your time,
And we're still here.
and we're still here. And our contact information, we'll put it back up in a minute. And if you have any other topics that you would like us to approach, as you notice, we're doing a graduate level webinar for which we charge very little, just to make sure that we have as many folks as possible. We thank you all for attending those, and we're doing these free webinars to also continue to disseminate this very important core competency to all manufacturers. Mixed model line design is a core competency to any manufacturer. You have to learn it, you have to use it, and is for you, the individual, is also a way to advance your career.
So any topics in the future that you'd like us to consider, just type it in the chat box on the right side of the screen.
Let us know.
Yeah, let us know, and we will consider it, as they say in Japan.
Yeah. Thank you all for your time. We're signing off now.